Jenny. So today I'm very pleased to welcome Kyla Drushka. She received her PhD from Scripps in physical oceanography in 2011. She has been working as an affiliate assistant professor, at the University of Washington School of Oceanography since 2015. She was a member of the post panel from 2015 to 2018 and co-chaired it from 2018 to 2019. And as some of you know, she's currently serving on two working groups as the co-chair of Ocean Uncertainty Quantification and as a member of the ASC Interaction Working Group. She's also co-chairing and has been a member of the NASA Product User Group Working Group. So she's involved in a lot of working groups and does a lot of mentoring, and her interest in observational oceanography, including ASC interaction, sub-mesoscale to mesoscale physics of the open ocean and ocean salinity variability, and a lot of other things. And today she's going to be talking about the tropical Pacific observational needs and process studies. Kyla, thank you so much for accepting to give us this presentation.
Thank you, Cecile, and thanks to Michelle and as well for organizing and inviting me, and to Jenny for organizing. So I'm going to talk about this upcoming workshop that US CLIVAR is organizing. And I'm going to start by giving some background on tropical Pacific processes and some of the knowledge gaps that we hope to cover with the workshop, and then just present a few details about the workshop. Okay, let's try that. Great. Okay, so the tropical Pacific is home to a multitude of interlinked, multi-scaled, coupled processes. And these are three very important words. Coupled, meaning that the ocean and the atmosphere are really highly coupled. They influence each other on many scales. Multi-scale, which is illustrated in the schematic here, and that there's energy on a huge range of scales, from the small and fast scales of cloud formation through diurnal, interseasonal, seasonal, and interannual scales. Those are all very energetic and interlinked in that those different processes all interact with one another. So we may understand diurnal cycles kind of well, or El Nino, but it's really necessary to understand how they interact with one another, and that's a really tricky problem. And we care a lot about the tropical Pacific dynamics because there's weather impacts around the Pacific, including in the US, and also global climate impacts. So I'm going to run through a couple of the processes that are very energetic here and important. So on these smaller scales, on the left, deep convection, so formation of clouds, and then larger mesoscale convective systems is an important process in the tropical Pacific. And this, again, involves strong coupling between the atmosphere and the ocean. So those air-sea fluxes of heat and moisture are really important for convection. Diurnal cycles are also really strong in the tropical Pacific. This is an image from Jessica Masick, who used data from a mooring in the tropical Pacific, and this shows temperature in colors in the upper 70 meters. And if you can see them, the vectors are currents. And what you see is a really strong daily cycle of heating that goes down to like 30, 40, 50 meters. And there's also a diurnal cycle of currents and shear and turbulence and mixing. And it turns out that representing this diurnal cycle in models is critical for getting some of these coupled processes right. And although this occurs on a pretty fast scale, the diurnal cycle, it has really interesting impacts and interactions with longer time scales. And again, representing the diurnal cycle in models turns out to be important for getting some of these longer time scale processes correct. The intraseasonal timescale, so like 30 to 90 days, is also really strong in the Pacific, in the tropical Pacific, especially in the western part. And on the left here, I'm showing a map of the sea surface temperature in the Western Pacific, and you see this big blob of warm water that's called the Western Pacific Warm Pool. And this is basically like an energy source for tropical air sea dynamics. And you get a lot of intraseasonal energy coming in from the Indian Ocean in the form of the Madden-Julian Oscillation, which is this strong coupled air-sea phenomenon, and it propagates in from the Indian Ocean and then spills over energy into the Western Pacific. In this western part of the Pacific, we also get westerly wind bursts. So this is now a Hofmüller diagram with longitude on the x-axis and time on the y-axis, and the colors show wind stress. And you see this series of wind bursts, these strong bursts. And this contour shows that edge of the Western Pacific warm pool. And those wind bursts basically shift that warm pool to the east. And this is, in fact, what one of the things that helped trigger that big 97-90 El Nino, is that warm pool shifted eastward, and ocean Kelvin waves got generated by those wind bursts, and that shifted the thermocline and all this heat toward the center and eastern Pacific. And that led to the El Nino. So there's these both strong atmosphere and ocean processes on intraseasonal timescales that turn out to be important for triggering El Nino, which is, of course, the sort of dominant tropical Pacific coupled air sea process, which we are, of course, sort of affects weather and climate globally. So there's very important reasons to understand what's going on in the Pacific in order to better predict ENSO. And so this is an example of some of the global impacts of El Nino. On the left is air temperature anomalies, and on the right are precipitation anomalies from the 2009-10 El Nino. And you see these global impacts on land in the US and worldwide. And these teleconnections means that we care a lot about what's happening in the tropical Pacific, because they're critical for prediction skill globally. In addition, climate models have persistent biases in the tropical Pacific, and a couple of these are shown here. The left panels show mean, and the right are the bias from an ensemble of CMIP5 models of precipitation rate on the top and SST in the bottom. And you see these very strong biases in the tropical Pacific. There's also biases in stratification and biogeochemistry. So we have a lot of work to do to understand what's happening here to correct these biases. Going to biogeochemistry, this is an incredibly important region. The tropical Pacific, and in particular the eastern tropical Pacific, is the largest source of CO2 to the atmosphere. So this is a map of net CO2 flux. And you can see this giant red blob where CO2 is going into the atmosphere from the ocean. And so understanding what's happening there is really critical to understanding the global fluxes of carbon. And so again, this is an example of some data showing the bias in CMIP5 models. The brown colors show observed CO2 flux in the tropical Pacific, and the blue colors show the multi-model ensemble. And you can see, first of all, that multi-model ensemble is quite a bit lower than the observations, so it's under predicting the amount of CO2 flux. And the error bars show the spread of these different models, and there's this huge spread. So the models are not getting this correct, and this is a problem. We've had a sustained observing system in the Pacific for a really long time. In the mid-1980s, the Tau array was developed, and this is an array of moorings spanning the equator, and these are shown in the yellow boxes here. And that was really built for El Nino monitoring and understanding. And as new technologies came online, it was supplemented by those technologies, so satellites, Argo floats, volunteer observing ships, drifters, etc. So we've learned a tremendous amount about tropical Pacific ocean dynamics and atmospheric dynamics from this array. However, things have changed a little bit. We know a lot more, and we know what we need to measure, and we still have a lot of open questions. So in 2014, the TPAWS 2020 project started. And this is a huge community effort to try to redefine what the tropical Pacific observing system looks like, based on what we now know that we need to measure better, and also based on a lot of new technology that's come out in the last 30 years. And so this the TPAWS project has been working extremely hard to really hammer out the details of what is needed in this sustained observing system. And they've produced in 3 reports, and the draft of their final report recently came out and has just been seeking community input. And I suspect it'll be published later this year. And this is the array that was proposed by TPAWS 2020. And I'll note that the details of this, that some of the specific details are still under discussion, but this is the general framework. Ooh. And the highlights are that this array of moorings would expand poleward to capture some of the processes that the near equatorial array does not capture. It'll make much greater use of Argo floats. This dark colored area means there's a really high density of Argo floats. Of course, we have a lot more satellites available than previously, and those are an integral part of the observing system, as well as other emerging platforms, particularly autonomous surface and underwater vehicles. And there's also a focus on increased biogeochemical measurements. The moorings remain the really critical part of the TAO array, and those will be improved in terms of their measurement capability. So the existing moorings are shown on the left, and the proposed new moorings for TPAWS are shown on the right. And what these have is, first of all, a lot better meteorology and air sea fluxes, potentially including some direct flux measurements. An increase in vertical resolution, so you can see there's a lot more instruments on the mooring lines here, particularly in the upper 50, 60 meters within the mixed layer, so you can really capture the diurnal cycles. And an increase in current measurements and salinity measurements, which were pretty sparse on the previous array. So the tropical Pacific observing system, what exists now, and hopefully TPAWS 2020, is absolutely critical for sustained observations, for forecasts and monitoring. But these instruments are pretty, they're far away from each other. Even as close as you can put these moorings, you're not going to capture subgrid scale processes. And there's still many small scale and multi-scale coupled processes and biogeochemical processes that will not be captured by this sustained array. And so in order to understand these processes, we need field experiments and model experiments that are dedicated to that. And that's really the goal of the workshop, is to define those experiments. And I've split some of our major knowledge gaps into 2 themes. You could organize them in a number of ways, but first, small scale processes. So these sort of subgrid scale processes and how they interact with larger and slower scale variability, like the intraseasonal and ENSO scale variability. Subgrid scale parameterizations and how those impact model biases and controls on biogeochemistry. And second, the boundaries, which tend to be poorly measured just because it's tricky. And so by boundaries, I mean both the ocean atmosphere boundary layer, and thinking of that as a continuum between the atmosphere and the ocean, and the interface in between them. Also the eastern and western sides of the basin, which tend to be undersampled because it's hard to put moorings there and it's hard to keep floats there. And finally, this eastern edge of the Western Pacific warm pool. So I mentioned there's that warm pool that shifts eastward during before El Nino events, and that is a moving edge, and it's really tricky to measure. And there's some very interesting atmospheric and subsurface ocean processes that go on there. but there's some work to do to understand those dynamics. So there's been a few, many community efforts focusing on some of these aspects, and I'm going to highlight a couple of these. First, there was a workshop put on by Kyla in 2018 called Bridging Sustained Observations and Data Assimilation for TPAWS 2020. And that was really one of the first efforts, I think, to really bring together the observational modeling and data assimilation communities focused on the tropical Pacific to try to understand what process studies and modeling efforts we needed. And that came up with a report and making a bunch of recommendations on process studies and strategies for observing and modeling this ocean-atmosphere interface. And after that, NOAA funded 8 modeling projects in support of 2 process studies that were proposed as part of the TPAWS 2020 effort. And these are, the first one is called PUMP, and that is an upwelling and mixing study in the Eastern Pacific along the equator. And the second one is on air-sea interaction at the eastern edge of the warm pool. And so those are ongoing projects that were funded by NOAA and will hopefully inform some of the future efforts. And then finally, in 2019, US Kyla had a really excellent workshop on atmospheric convection and air-sea interaction over the tropical oceans. So that wasn't limited to the Pacific, it was more general. And again, this brought together the observation modeling communities, as well as the ocean and atmosphere communities, and really got these groups talking to one another. And it, we had a lot of nice discussion and recommendations from that workshop, and it really highlighted this need for interaction between our different communities. They're surprisingly siloed ocean and atmosphere communities, given that we know that air-sea interaction is important. And so going forward, this is a priority. So building on these recent efforts, we are planning a new workshop that will take place on May 24th to 26th. This is the Scientific Organizing Committee. So the co-chairs are Charlotte DeMott and Anish Subramanian. And then there's some familiar US Kyla faces. And of course, we couldn't do it without the help from Mike and Jenny at US Kyla and the sponsors, NASA, NOAA, NSF, and US Kyla. And so there's 2 really high-level goals for the workshop. First, to provide a forum for these different communities to come together so people can interact. We can bridge conceptual gaps that our various communities have, and to develop observational strategies for understanding coupled air-sea processes and the representation in models. And the second goal is to get community input on the types of observations that we need for understanding these sub-grid scale processes, and also how we can leverage these observations past the field campaign to improve satellite retrievals, data assimilation, and parameterizations. And so there's 5 major themes of the workshop. First, multi-scale air-sea coupled processes. Second, data assimilation systems and reanalysis. Atmosphere and ocean observing needs. And finally, observing the ocean-atmosphere interface as a continuum. And the Scientific Organizing Committee has worked really hard to have a productive format to the meeting, despite it being virtual. And so we'll have targeted plenary talks on each of these themes, as well as panel discussions in breakouts. So we've carefully chosen panelists so that we can really tease out these questions as a group. And finally, there's a really strong emphasis on the poster sessions and making sure that the posters really touch on the questions of what these observational needs are. And finally, the outcomes of the workshop that we're hoping for are, first, interaction of these various communities. Second, input, which will hopefully lead to designing process studies. Third, identification of the observations that are needed. And fourth, informing the international community and try to build collaborative efforts. I think any successful campaign would involve partners in Asia and South America, Australia and Europe, who are all interested in this region. So The abstracts are accepted till tomorrow, so you have one more day if you have some great last minute ideas. Registration is free, and it's open till the week before the workshop. And we really encourage student and early career scientists to participate. So I will stop there, and I'm happy to take any questions.
Thank you, Kyla. So reminder, if you have a question, use the raise your hand button, or you can type it into the chat box. We have a question from Shane. Go ahead.
Good morning, Kyla. Good to see you. All right. So with this workshop, you're not going to try to evaluate again the new design of the observing system, right? So it's about process understanding. So maybe I missed it at the beginning, but what are the processes right now that we know that the redesign of the array is going to miss?
Everything that's small scale. Like the moorings are separated by, a couple 100 kilometers at best, right? And Argo floats, they might come up closer to each other. I mean, maybe there'll be some sail drones or something that go out, but really these small scale processes are not captured by the array.
Okay.
And something like this tracking the eastern edge of the warm pool, this is a moving boundary. And so you can kind of see it with satellites, but you don't see the subsurface processes. So that's another thing is like satellites do a good job of the small scales, but they don't capture anything subsurface. And also the array, although the moorings are equipped with really great meteorology sensors and maybe direct fluxes, they're missing, all of the measurements within that atmospheric boundary layer. You can't do soundings from a mooring. You can't really measure clouds from a mooring. So those processes are missed.
All right. So you had a slide about the outcomes. So would you say that one of the outcomes of the workshop maybe will be to recommend some process studies specifically? Okay.
Yes, absolutely. I think we'd really like to come out with recommendations for like the most necessary process studies that are also sort of tractable or doable.
All right, I look forward to that.
Ideally, right?
Awesome.
The goal is not to like come up with impossibly dreamy, never gonna happen process studies. It's really to be practical.
All right, thanks.
Yeah.
All right, there are a couple of comments and questions in the chat box. First one from William Large. He just says, Kyla, great summary, well done. The next one is a question from Fred Bingham. Kyla, have you had any discussions about rearranging the array globally in a unified way, for example, Rama or Parata?
I don't know. I don't think so. I'm sure there's someone else in this room who's better equipped to talk about this, but I don't think I understand that some of these other arrays are also going through a sort of evaluation process. But because the dynamics in each basin are distinct, I don't know that there is a unified way of arranging the moorings. But if anyone else from the Indian or Atlantic communities has any thoughts on that, please speak up.
I see a question from Michelle Gierach.
Hey, Kyla, sort of building upon what Shane had mentioned, and this may be too sort of forward-looking, but if the idea for this workshop is to look at or investigate, figure out process studies that are necessary that perhaps the existing layout excludes, would the idea then be based upon the outcomes of those process studies, augmentations to the existing array, or perhaps even a TPOS 2040? Sorry, and again, maybe too forward looking. It's just if those process studies find gaps that are necessary, would we constantly like evaluate sort of this observing system and improve it?
Yeah, I think that's a great way of looking at it. Is because a process study is only it can be as valuable as you make it, and it would have a lot more impact if we could make a bunch of measurements and say, oh, this is the critical thing that we need to measure in a sustained way going forward. So yes, I think it is looking forward significantly to imagine doing that, but it's a good thing to keep in mind as we plan these things.
Thanks, Kyla.
Yeah.
Any other questions for Kyla? I see a question from Allison Gray.
Hi, Kyla. Thanks for the talk. That was really great. I was wondering, you mentioned boundaries, and I was wondering specifically about more of like sort of the edges of the basins, if that's going to be one of the things that you're going to talk about in terms of process studies in the workshop, or is it more of the sub-grid scale sort of open ocean processes that are the focus?
Right now, I think the subgrid scale processes have been more of a focus, but this is a community workshop, and if a bunch of people show up and say we need to be measuring the boundaries, then that's on the table. So I think we are trying to guide the workshop, but also not be prescriptive. And it really should be coming from the community, not from the scientific organizing committee. So if you have ideas on how to, what we need to do with the boundaries, please come and bring those up.
Great, thanks.
Yeah.
I see we have 2 minutes left. I have time to take one more question if there are any. Go ahead, Shane.
So it's more of a comment for people in the audience, but we had 2 webinars last year for the post panel that addressed the other tropical basins. So we had Lisa Bill talking about the Indus review report, for which I believe she led the publication that reviewed the observing system. And then we had Greg Foltz also talking to us about the Atlantic tropical observing system. And there's a review report that must be out, maybe led by Bill Johns. But anyway, so to follow up on Fred Biggins' comment and question, I'm not sure there's been coordination between the 3 basins to try to find, common designs, most likely for, the reasons that Kyla brought up. But it would be interesting to look at the differences in the designs and see the different interactions. And then Anish is saying that there was a recent tropical basin interaction workshop sponsored by Cliva, International Cliva. Anyway, just a comment.
Antonietta, I see your hand raised.
Thanks, Kyla. Very nice to see you. I just have a little comment. I think that in terms of the 3 basins, I don't think that they were, I think the redesign was conducted independently, particularly I think for the Indian and Atlantic, actually the Cliva Indian and Atlantic panels were deeply involved in some of this redesign. But I totally agree with Kyla's response before that I think the processes are different, and so there are specificity in each basin that may require a different design. So I think one can learn in terms of best practices from one another, but maybe not necessarily in the detail of the design. And then a comment I would like to make is on the boundary, particularly the boundary of the basin. That's actually something that we discussed quite a bit in the context of the Pacific panel, because they are really critical. So the eastern boundary of the Pacific is very important. I think also is very related to the ENSO and it's an upwelling system. So I think it's also extremely important from a biogeochemical viewpoint. The western boundary, we have all the western boundary, western boundary current, particularly the low latitude western boundary current, and I think they are all in the dynamics of the equatorial Pacific versus how much goes to the Indian Ocean, to the ITF, are big open questions. And I think that also would require a lot of international cooperation. That I think was one of those were areas that TPOS was unable to fully address, or although they recognized the importance of that. And so I think maybe it's something that could be also discussed within the UN Decade of the Ocean, or I think may require a broader international collaboration than maybe what can be addressed just, within US agencies.
Thank you, Antonita.
All right, and I see some conversation going on in the chat box. So if you guys want to take the time to read that, I'll let it stay up for a little bit. But I think that we should start wrapping up today's talk. See, it's 12:32. So thank you so much, Kyla, for giving us this good overview of the tropical Pacific. Coming up on April 1st is our next pause panel webinar, and we'll stay in this region with a talk by Adrienne Sutton of NOAA PMEL. She's going to be focusing on the tropical Pacific biogeochemistry, so background gaps and open questions. So we hope to see you then. And again, as I mentioned, a recording of today's talk will be available by next week, so stay tuned for that. So thank you everyone for participating.